Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is on MCQ and the question is in front of you. Today's topic is a little interesting topic. Which of the following hydrocarbon has lowest heat of combustion? I request everyone, please pause the video, try by yourself, and whatever answer you get, please write in the comment box. If possible, please write the logic behind selecting the product also. Don't worry, after some time you have the right answer with explanation. I believe we have tried, so let's start. This video is going to be pretty interesting. Why? Because here the question is about the lowest heat of combustion or burning. Means in which case the released heat is minimum. Okay, so this is the question. In which case the released heat is minimum for hydrocarbons are provided. Before going to the details, let's learn a little bit about the heat of combustion. So it is actually the calorific value of total energy released when a substance undergo complete combustion or burning with oxygen under standard condition. More specifically, if I say it's a chemical reaction where hydrocarbon or organic molecule reacts with enough amount of oxygen such that complete combustion or burning can take place, and it ultimately result carbon dioxide and water. And it releases heat. Why? Because remember, this CO2 and water both are stable molecule. So compared to obviously hydrocarbons or other organic molecules. So when a stable molecule forms from an unstable molecule, it releases some amount of energy. And in this case, remember, this heat of combustion data is very reliable, and you can compare different hydrocarbon if the end products are same. I mean, number of carbon dioxide and number of water molecule produced, if they are same, then this data is very accurate. We can explain this thing from this curve also. So you can see this y-axis is energy and x-axis is reaction coordinate. And from there we can clearly say it's a exothermic or endothermic. By the way, from the previous discussion you understood that okay, total energy released, obviously exothermic. But how we can check? Now if you look at this is your reactant, it is a C9H10. By the way, do not get confused. If you look at all the option A, B and C, all have same number of carbon, same number of hydrogen. How can you calculate? You don't need to even calculate. Look at all are monocyclic and all have 4 number of double bond, all case. Okay, so the double bond equivalent is same for everyone. So therefore their formula is same. What is the formula? C9H10. So if you allow this C9H10 to react enough amount of oxygen or excess oxygen, then this carbon will be converted to carbon dioxide, 9 carbon dioxide and 10 hydrogen, so corresponding 5 water molecule it will produce. So this is, now we have observed that it is true that hydrocarbon, for example petrol, diesel, they are very inflammable, but in order to catch fire they need some amount of sparkling or fire, like that. Means some amount of energy needed such that they can burn and produce the CO2, water and heat, and that means it needs some amount of energy which we called as energy of activation. Okay, so this is the energy of activation. So you can expect this to this, sorry, up to this is the energy of activation, EA. Now how much amount of heat is or energy is released, you can understand from here. Okay, so this is the delta H value. Here product is less energy compared to reactant, so that means delta H, I mean delta H product minus delta H reactant is a negative value, means the reaction is exothermic in nature. Okay, so this is the discussion regarding it is exothermic or endothermic. Now a question, how can I compare? See, I told that everyone's formula is C9H10, although they are not same, but the final product is same. So what is the difference here? The difference is actually the energy level of the reactants. Okay, means you can understand, if the reactants energy lower, if the reactant's energy lower, means if the reactant is more stable, then released heat will be less. I guess that is our question. Who will release least amount of heat during the combustion? So now our actual question from here, who is maximum stable? So now if you look at all this thing, this is actually a 7-member ring. By the way, this is not aromatic. Why? Because this carbon is sp3 hybridized and it is not a conjugated system. So not that much. Now if you look at option B, here it is sp3 hybridized carbon. Yes, I agree, this 1, 2, 3 and 4 all are in conjugation. Here 1, 2, 3, but still it's not aromatic. But if you look at here option C, this benzene ring is student aromatic. So aromatic, remember, aromatic means it is very stable, means very delocalization, means very high stabilization. Delocalization is equal to stabilization. So since delocalization is very high, stabilization is also very high. Now if you look at the option D, what about this? By the way, this is a cyclooctatetraene methyl substituted. Now this is not an anti-aromatic, because these anti-aromatic means very high unstable. Aromatic means very high stable. Anti-aromatic means very high unstable. So molecule doesn't want to be unstable. In order to avoid that instability, it give up the planar arrangement and it attains a boat-like structure. Okay, so here everyone have a double bond, but they are not in conjugation, so they are not anti-aromatic, they are non-aromatic. So it is not that much stable. So who is maximum stable? Option C. Now based on this data, you can say if option C is maximum stable, so maybe position is like this, so the heat of combustion data is the minimum. So that is our question. So which of the following has lowest heat of combustion data? So which of the following has lowest heat of combustion? Obviously option C. Now if this question appear in your exam less than 30 seconds, how can you solve? For that purpose you need to understand one thing. Okay, if the hydrocarbon is very stable, then the released heat is very less. So who is maximum stable? Here only one option remain, aromatic. So it will be. And if you look at all are, they are conjugated but not that much stable like this. And obviously option D, it is not conjugated because it is not at all a planar. So this is a very interesting, easy conceptual question. I believe you have learned a lot, and if you really consider the content of my channel is worthy, then please help this channel to grow. And if you have any doubt regarding the logo of my channel, I request everyone please read this part, your doubt will be clear. So see you in my next video. Bye bye.